So we're going to finish up this chapter with the last two chemical properties that are varying across the periodic table. There are others that do the same thing, but we're just not going to worry about them. These are the last two we're going to worry about. The first one here is ionization energy. And what ionization energy is it is the energy that it takes to remove an electron from an atom. So if you have an atom sitting there and something comes along and tries to steal an electron away from the atom, it's going to have to pay for that electron. It's going to take energy to pull that electron away. Now, some elements are actually decently happy to have that electron taken, and some elements are going to make you pay a really high price for that electron. Let's try to think of how the atomic size that we looked at in the last video would affect this. Let's say we have a relatively small atom, and whoop, that one's so big it went off the screen, and a really big atom. Which one of those do you think is going to be easier to pull an electron off of? It's going to be the big one. The big one is going to be significantly easier to pull an electron off of because the electrons are not as tightly held. They're much farther away from the nucleus in the big atom than they are in the little one. And so because they're much farther away, they're not as strongly attracted to the nucleus, and so it doesn't take as much energy to pull them apart. It's almost like, having two strong magnets, and you put the two strong magnets, really close. You're gonna have to really pull to separate those. Versus, if you have multiple textbooks in between the two magnets, well, they're farther apart. It's not going to take as much pull to remove one of them from the other. So the bigger the element, the easier it is to pull the electrons away. So because of this, and because the way ionization energy is defined, being that low ionization energies means that it's easy to remove the electron, the trend for ionization energy is actually going to be the exact opposite of the trend for atomic radius. So if you remember, atomic radii increased as you went down and as you went to the left, so that overall, down and to the left, gave you larger elements. Ionization energy increases as you go up and to the right. So ionization energy increases in the exact opposite direction as the radius, which means that things like fluorine and the noble gases are going to have very high ionization energies. Those elements are very happy the way they are. They don't want to lose electrons, they want to gain electrons. And so this here, that's fluorine, by the way, and it has a higher ionization energy than everything except neon and helium. That is very high ionization energy. It's very, very difficult to pull an electron off of fluorine. It's even more difficult to pull an electron away from helium or neon. But we don't really do chemistry with the noble gases very often. So the trend here, once again, is the exact opposite of atomic radius. And even though the lithium and sodium and potassium and rubidium, those actually want to lose an electron, it still does take some amount of energy to take the electron away. The electron is still attracted to the nucleus of that atom. It's just not going to be as difficult to pull away as other electrons from other elements. The last property we're going to look at here is metallic character. Just to remind you of what the typical properties of metals are. Metals tend to be very malleable and ductile, which means that they are easy to work with relative to some other materials. You can shape them into different things. They also tend to be shiny and lustrous and reflect light. Most nonmetals do not do that. Most nonmetals are very dull and non-reflective. Most nonmetals are also very brittle. I don't know if you've ever tried to form something out of charcoal, but charcoal, which is mainly carbon, which is a nonmetal, you're not making too many buildings out of charcoal. Those tend to crumble pretty easily. Metals also conduct heat and electricity very well, and most nonmetals are electrical and thermal insulators. Most metals form oxides that are basic and ionic, whereas nonmetals form acidic and molecular oxides. Most metals form cations when you put them in solution, with very few exceptions. Nonmetals actually are kind of a mixed bag. They mostly form anions, but you can actually form some cations as well with nonmetals. And then lastly here, metals tend to lose electrons in reactions. They tend to be oxidized, whereas nonmetals tend to be the things doing the oxidation. They tend to be reduced as a result of that. So metals and nonmetals really do have very, very different properties. Metallic character, most of the time we should not have a hard time remembering which directions metallic character increases, because hopefully you remember where metals are on the periodic table. Hopefully you can remember that the nonmetals are up here and the metals are over here. And then the metalloids are kind of in between here. And so if you can just remember where things are on the periodic table, you don't even really have to remember the trend, because you can just think, okay, pick a random spot, here. Which direction do I need to go in to run into metals? Well, go to the left, and eventually you will come in contact with metals. And if you go down, in this case, I believe that is actually a metal. I believe, well, no, radon wouldn't be a metal. But if you go down-ish here, down and to the left, you would run into metals. So going to the left and going down gives you metallic elements eventually. So going to the left and going down increases metallic character. So the metals over here, the germaniums and tin and gallium, don't have quite as much metallic character as something like a barium or a strontium. So the overall trend here is actually the same as atomic radius. So atomic radius and metallic character have the same overall trend in that they increase going to the left and going down. So you really only have two trends to remember: down to the left and up and to the right. And you just have to remember that the down and left is the metallic and radius, and up and to the right is ionization energy. And that's it. That is it for this chapter. So, good luck on the homework for Chapter 9. If you have any questions, feel free to shoot me an email, and I will get back to you as soon as I can. See you in the next chapter.